In this video, we're going to go over the free response question number 2 from our Unit 6 review. Okay, so we've got two fire stations where one fire station in the northern part of town responds to calls up there, and the other fire station in the south responds to the calls to the fire department in the southern part of the town. So one of the town council believes that the two fire stations have different mean response times. All right, and tells you how they're measuring that. And they collected some data from 50 random calls to the northern fire station and 50 to the southern fire station. Gave us some sample statistics. So we're going to do a 95% confidence interval. So the first thing I do here is start going through my assumptions and conditions. And the first assumption I'm going to say, we've got two groups and they're not related, even though, yes, they're the same town. We have no reason to believe that one call happening is going to impact another call in the other part of town. So I'm going to first say that one response time to a call will not affect others. Now, one of the assumptions we need to make for a two-sample t interval, which is what we're going to be doing here, is we do need to assume that the two groups are independent. I'll do that at the end, but you can do it here if you want. It's your choice. So we have random samples. So both samples of 50 calls are random. And I don't actually know about all of the number of calls in this town, but if we're doing, the 10% condition and do n times 10, which is 50 times 10 equals 500, we need to make sure that there are more than 500 calls in whatever we're deeming to be the population, whether that's in the last year, last 10 years, in the existence of this town, whatever we decide it to be. Okay? We don't actually have any of the data values for these 50 calls. So we're going to assume, right, so the population histogram of response times is normal. And if I had the data values, I would make a histogram for our data, but unfortunately we do not, so I just have to assume that is not going to be an issue with our sample sizes of 50 calls. Again, 50 is not like a super large number, but it's also not super small. It's not like 5 or even 10 calls, so I'm probably not worried as much about this because my sample size isn't extremely small. All right, so my last assumption will be the two fire stations are independent of each other. So I'm not real sure if they have firefighters who work at both of the stations. That would be an issue in terms of dealing with independence. Okay, so I'm ready for my statement to say that the conditions have been satisfied. So the conditions have been satisfied. So I will use the T model with, I'll leave a blank here because I don't know how many degrees of freedom I have yet, to run a two-sample t interval. All right, so I'm going to write down the stuff that I do know. I do know, you know what, I actually am not going to, oh no, I will be able to, that's fine. My sample sizes for I'm going to say the northern one is 50. Sample size for the southern is 50. They told me the average time for for the northern station is 4.3 minutes. For the southern station is going to be 5.3 minutes. And then for the standard deviation for the northern and the standard deviation for the southern is 3.7 and 3.2. So 3.7 and 3.2. Okay, so let's go ahead and write down our formula. Our formula is going to be the difference in these two means. So y bar northern minus y bar southern equals plus or minus, I don't know what t star is, times the standard error of that difference. All right, so I'm going to plug that in and get 4.3 minus 5.3 plus or minus, I don't know yet, times, and here we have the square root of 3.7 squared over 50 plus 3.2 squared over 50. All right, so here's where I go to the calculator to get my actual answer. I'm going to turn it on. Maybe not. Let's see. Turn it on. There we go. I'm going to do stat, and then I'm doing a 2-sample t interval, which is going to be number 0. All right, I have statistics, right? So I have to go over to there. My first average was 4.3. My first standard deviation is 3.7. My sample size is 50 for both. Then for the southern fire station is 5.3 is the average, standard deviation of 3.2, and a sample size of 50 again. It has a confidence level of, I already forgot, I think it's 95. Yep, 95% confidence. So 0.95, not pooling, and let's calculate it. All right, so my degrees of freedom is 96.005. 96.005. So later on, you don't have to do this, but I will find my t star. And my interval is going to be negative 2.37 to positive 0.37. All right, so before I write down my answer, I'm going to do second vars and do inverse t. We're doing a 95% confidence level, so if I split 5%, that's 0.025. And our degrees of freedom is 96.005. So we get a t star of 1.985. 1.985. Again, not necessary, but just want to show you how it's getting closer to the same z star that we would use if it was proportions. So let's write my answer. I am 95% confident that the average difference in response times is between negative 2.37 and 0.37 minutes. Okay, now I've tried to do my best to help you guys figure out how to answer letter B in previous scenarios of problems like this. And it says in letter B, does the confidence interval in part A support the council member's belief that the two fire stations have different mean response times? All right, so what I would notice is my interval is not exactly centered around 0. It looks like it is further to the left into the negatives. So it does look like, as we can see in the sample statistics right here, right, you can see that the average response time for the north and the south in just this sample, the north on average was a little bit faster. But in terms of using this to then have enough statistical evidence to say that there is a difference in the mean response times, unfortunately, the answer is no. This is not going to do that because if you notice, the interval does contain 0. And if the interval does contain 0, then 0 is a plausible value for the difference in the average response times. And if the difference is 0, that means their response times are the same. So even though I don't know if that's true, all right, I'm going to say the interval contains the value of 0 minutes because 0 minutes is a plausible value for the average difference in response times. Let me get a little space there. In response times, this interval does not support the council members' belief that the two fire stations have different mean response times. And that is it. All right, so that is number 2.